Welcome everyone. I am Jason Glazer, your host today to discuss the SPC 229 schema data groups for the heating, ventilation, and air conditioning system, heating system, and cooling system. Remember, for the first week after this video is posted, we encourage discussion by email of any issue found. Hopefully all issues will be identified during this week. After that, we will have a letter ballot, which will also last about a week. If minor issues are raised during the discussion, then they will be included in the letter ballot. But if it's something complicated, it'll be referred back to the schema working group and brought up again in a future ballot. Today's video is the first of probably 3 videos covering the air side of HVAC in the schema. We started with the top level data groups today, and we'll get into some more of the detailed data groups on upcoming sessions. While the water side HVAC and air side HVAC might be approximately the same level of complexity, the water side decomposes into an architecture that's relatively simple. Air side, unfortunately, is less clear-cut on how to break up the various real-world components into data groups. If we were to ask 5 mechanical engineers on how to break up the parameters to describe the air side of HVAC system, I personally think we would end up with 5 different approaches. Given that, I hope everyone will appreciate that there is no right answer, but instead we'll be making sure that the proposed approach is a workable solution. That's all we can really aim for. The schema working group has had many calls about the topic of the air side HVAC architecture, which followed calls by a smaller task group to make a recommendation on the overall approach. We have continued to refine it, and in fact, updated some notes related to this just a few days ago. Remember that the schema is intended to aid in validating that the transformation between a user's model and the baseline model is done correctly, and is not intended to be a universal model of everything that can appear in a building or be modeled in a simulation program. So where we're starting today is on the heating, ventilation, and air conditioning system. So that's located right here in the center of your picture. And we're also going to cover heating system and cooling system. Nearby and very related to these are fan system, air economizer, and air energy recovery and fan, as well as terminal. So those we won't be covering today, but we will be covering them in upcoming videos. What you might want to note that the terminal references back to the HVAC system. Besides that, I wanted to show you where this all fits in the overall scheme. So the heating, ventilation, air conditioning data group is part of building segment. Building segment is part of building, which is part of rule set model instance. And that is ultimately part of the root data group, ASHRAE 229. Another perspective on this comes from a presentation that was made a while back describing the air side hierarchy. And again, it shows that a couple layers deep at the same level as zone is this heating, ventilation, air conditioning system, which references fans, cooling system, heating system. Fan system has several things that it references or includes: fan, air economizer, and air energy recovery. Cooling and heating systems reference the fluid loops. And to connect everything up, the zone has a data group called terminal, which references the HVAC system and the fluid loop. So go back to the schema now and start talking about that. So like every other data group, the heating, ventilation, and air conditioning system data group has an ID, reporting name, and notes. And I apologize, sometimes I may be calling this the HVAC data group instead of heating, ventilation, and air conditioning system. It's It's a shorter name, but technically we have agreed not to have a lot of abbreviations in the schema, so that's why it's spelled out this way. So it basically is just a holder of other things. It has a fan system that it references, and this is basically a child's data group of it. And then there's a heating system, a cooling system, and a preheat system that are children of it, and the status type, which is enumeration. I'll get to that in a second. So you may note that each one of these references or has a child, a single instance of them. So there's one fan system, one heating, one cooling system in general with underneath the heating, ventilation, and air conditioning system. But for preheat, it's so similar to heating that we basically just have a second place that you can reference another heating system that serves as preheat. So the status type, let me show you about that enumeration. So this is something that would be applicable for Title 24, and it needs to describe whether each HVAC system is new, altered, existing, or existing plus new. Those are enumerations from Title 24. All right, so let's move on to heating system. So once again, heating system has an ID and reporting name and notes, just like every other data group. There's a heating system type, and that's an enumeration. I'll go over that in a minute, and I'll also read this note to you after I've gone over the overview of this. There's an energy source type, which we've talked about before. It's an enumeration. It references a hot water loop. And that makes sense for a heating system. It has a design and rated capacity. For heat pumps, the design and rated capacity, for example, might be different. For furnaces, they're probably the same. Water coils might also have a different design and rated capacity. Oversizing factor is the factor that's already been included in the capacity that is an indication of how much oversizing has been done. So that's used for some rule sets that specifically have rules about oversizing. And then there's a flag for whether it's auto-sized or not, what the heat coil set point is, and then there's two parameters about efficiency metrics. One is the values, and one are the actual metric options. This is actually a list of values. So there might be 1, there might be 10 different values described for this. And we'll go through the different heating metric options that appear. That's an enumeration. And then there's types of heat pump auxiliary heat. That's an enumeration we'll go over. And then there's a couple shutoff temperatures. One for the high shutoff temperature for auxiliary heat. So that's the temperature at which auxiliary heat will no longer be allowed to be turned on. And then there's a heat pump low temperature shutoff temperature for the lowest temperature that the heat pump can operate on in heat pump mode. And then there's also a humidification type, which is an enumeration. So let me go through those enumerations next. So the energy source options, we've talked about this one before. The enumerations are pretty much what you'd expect: electricity, natural gas, propane, fuel oil, and something other than that. We've seen that in other data groups. And, excuse me, I always seem to lose where these heating enumerations are. Let me just search for them. There we go. So heating system options, also probably a list that you could have figured out. Basically heat pump, furnace, electric resistance, or fluid loop. And then there's none and other, just to be complete. Heat pump auxiliary heat options would include electric resistance or furnace, none or other. And humidification options, adiabatic, none or other. Probably the most complicated enumeration is this heating metrics option. So remember, there can be more than one of these if it's appropriate. So there's a heat pump coefficient of performance at high temperature. So that would be typically the 47 degree point. And then a heat pump coefficient of performance low temperature, which would be at like the 15 degree. And then there's ones with no fan. So if, for example, Appendix G wants the no fan values of those, so those would be put in there as an option. And then for furnaces, there's thermal efficiency, combustion efficiency, AFUE, and then for some seasonal factors for heat pumps, there's the HSPF and HSPF2. So those are all the enumerations for heating system. So next, let's cover cooling system. There it is. All right, so cooling system, like all the others, have had an ID, reporting name, and notes. And then this cooling system type. Oh, I just realized I never read you the this long note. It's actually the same note. It appears in heating system type, cooling system type, as well as terminal, and it's to help people differentiate where things should be described. So system configurations that are typically at the zone and include a compressor, such as PTAC and PTHP, window air conditioners, and window heat pumps, should be reported in the schema using heating system and cooling system. Systems that include gas or electric furnace should be reported in a schema using heating system. System configurations at the zone that only include fans and coils, such as 4-pipe fan coil, 2-pipe fan coil, radiant system, baseboards, and chilled beams, should be reported in the schema using the terminal. But their central components for chilled water, hot water systems should be described in heating system and cooling system. Evaporating cooling systems should be described in cooling system. Passive diffusers with no coil or fan should be described in terminal. So as I said, that same note appears in several places in the schema, and it's just to basically help people understand when there's ambiguity where something should be described. All right, moving forward again. So there's total, very much like the last time, there's design and rated capacities, but for cooling equipment, there's not just for the total cooling, but there's also a sensible cooling capacity for each, and those are numeric inputs. Then there's an oversizing and is oversized flag or Boolean, just like we talked about in the heating system. And also, like in heating system, there's a link to the chilled water loop, or to a water loop, in this case chilled water loop, as well as a link to a condenser water loop. Normally a chilled water loop would be the most common to reference, but there are some system configurations that might provide that might need a condenser water loop to be referenced. Like heating systems, there's a list, again, of metrics and values for those metrics. There's a dehumidification type that we'll talk about, and then a cooling turn-down ratio, which is basically just how low the cooling capacity can be to turn down prior to simultaneous heating and cooling occurring. So let's see, there's a couple of enumerations that we should go through based on this. There they are. So the cooling system options are direct expansion, fluid loop, and non-mechanical. For dehumidification options, there's mechanical, cooling, desiccant, and series reheat, series heat recovery. And for cooling metric options, again, this is a long list of different metrics that apply to cooling equipment. There's full load coefficient of performance, full load coefficient of performance, no fan, which doesn't include the indoor supply fan. EER, SEER, SEER2, IER, IPLV, and then combined energy efficiency ratio, none, and others. If anyone sees something that we've missed here, please let me know. All right, so that's basically everything. So thanks for watching the video. As a reminder, if you have any questions or comments on the schema, please reply to everyone with your comments, and hopefully it can be resolved as part of the ballot. About a week after this video was released, you should be receiving a letter ballot from ASHRAE to vote on this. So thank you very much.